Good morning, everyone. Today we're going to learn in Chapter 1 Physics reflection of light at curved surfaces. Now, what is a spherical mirror? A spherical mirror is a mirror whose reflecting surfaces is a part of a hollow sphere of glass. It means that it is a ball which is made up of glass. So the spherical mirrors will have curved mirrors in them. And each of the curved mirror is a mirror with a curved reflecting surface. The surface may be either convex or concave, because spherical mirrors are made up of concave and convex mirrors. Now we said that there are two mirrors in a spherical mirror, right? The concave mirror's reflecting surface is on the inner side of the curved shape. And for the convex mirror, it is on the outside or the bulged part of the curved surface. Let us see how each of the curved mirrors will reflect an image. In a convex mirror, the image will be diminished, erect, and virtual. Here, virtual means that we cannot get the image on a screen. So it is used as a rear view mirror. So we use convex mirror in shopping malls, parking areas, and in motor vehicles. So why do we use them in motor vehicles? Because it is called as a rear view mirror, right? So farther objects will appear near, and it will be also erect. If we use a concave mirror as a rear view mirror, the image will be inverted and we will have a lesser view of the vehicle behind us. So this is the reason we use only a convex mirror as a rear view mirror. Now we will move on to concave mirror. In a concave mirror, the objects will appear smaller than their actual size. This will be used by the ENT doctors to see the teeth, your ears, your nose, etc. Concave mirror is used in the headlights, shaving mirror, and solar cookers also. Characteristics of a concave mirror are: the image formed will be inverted, it will be smaller than the size of the object, and it will be a real image. Meaning of real image is that the image formed can be caught on a screen. Now, how are all these images formed? To identify how the image is formed, we have to know about the pole, the focal length, and the center of curvature, and the principal axis. Center of curvature. When all the normals will converge or diverge at a point, this is called as the center of curvature, which is denoted by a capital C of a mirror. Midpoint of a spherical mirror is called as a pole, which is denoted by a capital P. Now about the principal axis. A line which joins the pole and the center of curvature is called the principal axis. Radius of curvature. Radius of curvature and the center of curvature both are same. So the radius of curvature is a line joining from the center of curvature at any point of a circle is the radius of curvature. So technically we can just say that in a circle we say always the midpoint is called as the point O, right? So when we join the point O to any surface on the circumference, it will be the radius of the circle, right? So that is what here radius of curvature means. It is just like the radius of a circle. Principal focus or the focal point. When the parallel beam of light rays, all of them which are parallel to the principal axis, they will converge or diverge at a certain point. This point will be called as the principal of focus or the focal point. The focal point is denoted by a capital F. There are conditions to get a parallel beam of light rays. The source should be far away at infinity, and the source should have high intensity of light, and this kind of source is our sun. Activity 1. Now this is just a summary for activity 1. First we have to take a small piece of foam or a rubber sole. Take some pins, place them in a straight line having equal distance between them. When the rubber sole inverts and all the perpendicular pins will meet at a certain point, this will be known as the center of curvature. When all pins will meet certain point, all the pins will meet at a certain point inwards, bent inwards. So we can say that a convex mirror is a converging mirror because all of the points will meet at a certain point converging at the center of curvature. Now for a convex mirror, now take the rubber sole and bend it outwards. All the perpendicular lines will diverge. When all of these lines are extended backwards, they will all meet at a certain point. This will be the center of curvature of a convex mirror. So when all of the rays in a convex mirror will diverge, all of the rays are extended backwards to a certain point. That will be where the center of curvature will be. So we can say that a convex mirror is called as a diverging mirror. And this is one of the important bits. The geometrical center of a circle is a tangent. Now observe figure 3. You can see that there's a small block of thermocol over there, and it has two pins at equal distance between them, perpendicularly standing. There's a candle at different positions in figure 3. In the first one, you can see that the candle is close to the block of the thermocol, so we can see that the pin's shadow is diverged. When the source is far away, they become parallel again. And if we move the source of candle even more farther, then the intensity will be so low that we cannot see the shadow. So this tells us about that the beam of light parallel to the source have enough intensity when it's at a long distance. Already read about this, that there are conditions for the parallel beam of light. So the source should be at infinity and the source should have high intensity, and this source we said was the sun. And activity 2, you have to take a concave mirror and the source of light, the sun. Hold the concave mirror such that the light falls on it. Now take a piece of paper and slowly move it in front of the mirror and find a point where the small and brightest point is seen. This point will be the point of focus or the focal point. So when the light beams are parallel to the principal axis and they converge on a convex mirror, they will meet at a certain point. This point will be known as the focal point. And for a convex mirror, all the parallel rays will appear diverging from the reflection point. And when these reflected rays are extended backwards, they will meet at the point of focus or the focal point. So in a concave mirror, the points will be converged at a certain point and we'll get a bright small image. And in a convex mirror, all the points will be diverged at a point and we will extend the rays backward. Find the focus point or the focal length. Formula for finding focal length is R is equals to 2F. Means here R is denoted as the radius of curvature. When we half the radius of curvature, we will get the focal point. Or we have to find the radius of curvature, then we have to multiply the focal length with 2 and we will get the radius of curvature. Concave mirror, the center of curvature will be outside and the focal length will be also outside. While in a convex mirror, the focal length will be inside the mirror and the center of curvature will be inside. So the image formed will be inside. So it is not real, or it is a virtual image. When we said inside a concave mirror, the center of curvature will be outside and the focal point will be outside. This means that the image is real. So we are getting the image not inside the mirror but outside on a screen. Now we will see about the lab activity. Aim to observe the type of image and measure the object distance and the image distance from the mirror. Materials required: a candle, paper, concave mirror. You should know about the focal length of this concave mirror, a V-stand and measuring tape or a meter scale. Precautions: adjust the screen without disturbing the incident and the reflected ray, and the size of the object should be the same height of the mirror which is placed on a V-stand. Procedure: take a convex mirror on a V-stand. Place the object on the principal axis at different distances from the mirror, like at the center of curvature, beyond the center of curvature, between center of curvature and the focal point, at focal point, between the focal point and the pole. Adjust the screen so that you can get a sharp image on it. Measure the object and the image distances. Note down the values you have gotten in the following table. Observe and mention if the image is erect, inverted, or real. You can see the table in page number 6, table 1 and table 2. Observation: you can see the given table right now on the screen. The position is between P and F, which is the pole and the focus. So the position of the image will be behind the mirror. The image will be enlarged, so it will be bigger than the actual object. And the image will be erect, so it's like on top of the principal axis. And the image will be virtual, so you can see the image only inside the mirror. And the object is placed at the focal point, the image will be at infinity. And because it is placed at infinity, we cannot know the characteristics of the image. So these three places will be blank. When the object is placed between F and C, the image will be beyond C. So it will be beyond the center of curvature, and the image will be enlarged. So it will be bigger than the object, and the image will be inverted. So it will be below the principal axis, and the image will be real, so it can be caught on the screen. And when the object is placed at the center of curvature, the image will be also at the center of curvature. So it will be the same size as the object, so it will be the same size. And the image will be inverted, so it will be below the principal axis. And the image will be real, so it can be caught on the screen. When the object is placed beyond the center of curvature, so the image will be formed between the principal of focus and the center of curvature. So the image will be diminished, so it will be smaller than the size of the object. And the image will be inverted, so it will be below the principal axis. And the image will be real, that means it can be caught on screen. When the object is placed at infinity, the image will be at focus, and the image will be point size, means it is very small, it's like a tiny point. And the image will be inverted, so it is below the principal axis. And the image will be real, so it can be caught on the screen. It's just the characteristics of concave mirror, but when we go to the convex mirror, the image characteristics will be always diminished, erect, and virtual. So whichever point you keep the image at, all the images will be diminished and all the images will be erect, and all of them will be virtual, so we can only see them inside the mirror, not outside on a screen. That is it for now. We will see you later in part 2.